Good morning, students. Today we are discussing a topic of first year, some basic concepts of chemistry. This chapter links high school to college. You have studied many things related to atoms, molecules, compounds, some of its properties in the high school level. So, taking this, we are explaining in detail and applicative part and extension part in the chapter some basic concepts of chemistry. This is very important chapter for both first and second year. The reason is the weightage is also good and the concepts which are applicative concepts. We use the concept what we are studying in this chapter throughout chemistry. Hence, it is very important. So, if you look into the weightage or trend analysis for a NEET, its total percentage share is around 2%. For a board exam, it is 10%. Even for JEE exam, we can expect at least one question from this chapter. So it's a very good to study and to practice. Okay, what we are studying under the heading some basic concepts of chemistry. See, if you look into overall chapter segregation, it starts with matter. So classification, first one is matter, then its classification. One is based on the physical properties or physical appearance, and based on chemical analysis or a properties, we are segregating the matter into two types: physical method, another is chemical method. After this, we are studying law of chemical combination. Law of chemical combination. Okay. Then Dalton's atomic theory. Then Dalton atomic theory. Then atomic mass, molecular mass, mass number. This is one part. After this, if you are familiar with these topics, the next chapter or next topic of this chapter is very important, that is a mole concept. So you should be familiar with these three: atomic mass, molecular mass, mass number and all. If you are unfamiliar, the rest of the topics will be difficult. Okay, but I make you to learn in the easy way, not to worry. So this is first part of this chapter. If you come for the second part of this chapter is mole concept. Mole concept followed by stoichiometry and stoichiometric relationship we are discussing, mole concept and concentration terms. Concentration terms. These are all the main topics we are discussing under heading some basic concepts of chemistry. Let us start with the first topic of this chapter, is matter. Let me ask very simple question. What is a matter? See, matter is a substance which is a surrounding to us, which has a mass and occupies a space. It is considered to be a matter. Anything you take. So I am standing here, surrounding to me have many things. Pen, board is there, and I am speaking, that mic is there. So all these are all considered to be matter. Anything, whatever you are imagining, it should be a part of the universe and it should occupy space, and as a mass is considered to be a matter. See, this matter is classified physically. So based on microscopic property, it is classified into solid, liquid, gas, plasma, and we have one more state that is called Bose-Einstein state. We have fifth state of matter. Okay. Now we are discussing in brief about solid, liquid, and gas. What is a solid? How do you identify the given matter is a solid? See, to identify the nature of a matter, we are not performing any experiment. Just by looking into this and through a feel, we can identify whether it is a solid, liquid, or gas. For example, take this pen. See, if I ask what is a state, you are telling it is a solid. Why means how? How do you define this? Yes, you can say it is a hard material and it has a particular length and it is having a mass and it is occupying a space, hence it is considered to be a matter. So if I ask, take water, what is the state? If you look into the water, easily you can say it is a liquid. How that water differs from this? You can say how it differs from this pen. So water means it has no definite shape. Definite shape is not there. It takes the shape of the container. And it moves from one region to another region, or it flows. This flowing property is one of the major property through which you can identify liquid. Suppose if water is spilled on the floor, what happens? It moves to certain distance. It moves. Suppose if I keep this pen on the desk, it won't move by itself. So that difference can be seen. The third state is a gas. How this gas? Usually this gaseous state is invisible. For example, oxygen, what we are inhaling, carbon dioxide we are exhaling, nitrogen is there, helium, neon argon, nitric oxide, nitrogen dioxide. These are different types of gases. So we can feel, but we can't see the gases. Then how it differs from solid and liquid? So at least if you take a water, put it into a glass, you can say water is there. If I ask what is surrounding to you, you can say gas, you are feeling but you can't see. But how this gas differs from solid and liquid? So these gaseous particles which are away from each other, and the force of attraction is very less, it can undergo a process called compression. By these properties, easily we can identify the gaseous state. So this is a physical parameters to define or explain solid state, liquid state, and gaseous state. no doubt. If I ask you a very simple question, you take water in a beaker. Water in a beaker. Then you take ice. Then water vapors. Look here, water, its composition is H2, no doubt. Ice is nothing but H2. Water vapor is nothing but H2O. Chemically, all these three are same, no doubt. But the state is different. How you are saying the state is different? Just looking into this, you are saying it is a liquid state. This is solid and this is a vapor state. How these molecules arranges to give different state is the question. How the difference can be explained in chemical way is the next part. Let us discuss one by one. Take water, H2O liquid, H2O liquid. In the liquid state, the molecules are close to each other. See, this is one molecule, other molecule, other molecule. It's a close, and this is said to be intermolecular space. A small intermolecular space can be seen, and the force of attraction between the molecules are less in the case of liquid. So force of attraction between the molecule is less. As a result of a weak force of attraction between the molecule, it can float on the surface very easily. But these molecules cannot be compressed. Why? Means when a force is applied, what happens? It comes closer due to presence of electron cloud. The repulsion takes place. Hence, liquid cannot be compressed like gaseous molecule. That is one reason. It cannot be compressible. So the flexibility of the liquid state, it takes a different shape as per the shape of the container. So this is one main difference. That is a force of attraction between the molecule is less. You take H2O solid. Have written solid. How this differs from a liquid? Just observe carefully. Okay. What is the difference between first and second? The first and the second difference is just observe carefully. Here the space between the molecules are very less. This is said to be intermolecular space. No intermolecular space or negligible. Why it is negligible? The reason these molecules are compactly arranged. They are tightly bonded together. As a result, it has definite shape. Here, the force of attraction is very high. Very high, and interatomic or molecular space is very negligible, or we can say no. This does not undergoes compression. Compression is not possible. As a result, it has definite shape. It has a mass. So if I ask you what is the shape, easily you can say this is a cylindrical in shape. What is the shape of this board? You can say it is a rectangle or a square. So this shape is due to compact arrangement. The molecules are tightly bonded, hence it won't flow like liquid. This is one. Then if you take another state, gas, that is water as usual, water, gas, this is called vapors we can say. Just observe, I'm writing. Can you find any difference in the arrangement of the molecules? Yes, a major difference is there. In the first case, the molecules are packed loosely. In the second case, the molecules are compactly arranged or tight arrangement can be seen. In the case of a gaseous state, the molecules are away from each other. They are away from each other. Away from each other, you can see they are far away. As a result, this molecule does not have definite shape. This can be compressed easily. If you apply pressure, this comes close together and undergoes a process called compression. Once that pressure is released, it moves away from each other. So, based on the arrangement in the molecular level, microscopic level, we are classifying the state into solid, liquid and gas. The major difference among all the three is intermolecular force of attraction, intermolecular space. This is the major difference. How physically we are classifying matter into solid, liquid and gas. We are not discussing anything about Bose-Einstein or plasma state for this level. Okay, this part is over. Next is matter is further classified chemically. Into what? See, if you look into this, based on the physical state, we have classified solid, liquid and gas. We are very much focused towards chemical classification of a matter. How matter is chemically classified? It is classified into two types. One is mixtures, another is pure substances. This is the major classification based on chemical nature. Based on chemical nature. Look here. The name itself states a mixture. What is the meaning of mixture? We have heard. Mixture is a substance which is made up of two or more substances. It is said to be a mixture. It is literary meaning. No doubt, we are also applying the same thing here. Pure substance means if you take anything, the entire components are same. There is no difference from one level to another level or from one part to another part. Such is said to be a pure substances. So now we are discussing one by one. Mixture. So as I said, a mixture is nothing but it is made up of two or more substances. Let us take a very simple example for a mixture. Then it is very easy to understand. Daily we used to drink coffee, tea, right? So just imagine you are drinking a coffee. Okay, first sip. What is the taste? Sweet in taste. Drink second sip. Sweet in taste. Again you drink. The taste remains same from first sip to last sip. Why? Just think of it. The reason is very simple. So tea is not a pure substance because it is made up of water, milk, sugar, tea powder and other ingredients are there. All these ingredients are blended or mixed equally, uniformly. As a result, you won't find a different taste from first sip to last sip. Throughout, you will find the same taste. Why means whatever the components you have taken is distributed uniformly from beginning to end. So, such substances or a mixture is said to be uniform. Uniform means throughout the solution or a substance you find the same type of composition. For example, this a simple example, you take sugar water or salt water. It is a mixture. Why it is a mixture? Because there are two components, one is sugar, another is water, hence it is a mixture. Okay, so make a solution, keep it aside. If you look into the composition in the first layer, it remains same. Middle layer, same. Any part you take, the composition remains same. So, where the solution shows uniform distribution of the components and the same composition is said to be homogeneous mixture. Any example can be given. As I said, salt water, sugar water, HCl solution, nitric acid solution, copper sulfate solution. So there's example for homogeneous mixture. Then come for heterogeneous. What is the meaning of heterogeneous mixture? So heterogeneous mixture, you might have heard about heterogeneous mixture. Simple example I will give. Take a beaker, add water. Water is added. To this, add oil. Any oil you can add it. Fine. Just shake it. In spite of shaking or agitation, what happens? After a few minutes, you can find different layer. So, this is oil, this is water. It gets separated. It is not a pure substance because you have two components. One is oil, another is water. It is a mixture. But the difference is, in this case, oil is separated from the water. It is not mixed uniformly. So up to this, if you take the sample, you find only oil. Later, oil and water components. Bottom, you can get only water. What happened in this case? Here, the two components what you have taken is not mixed uniformly. Those mixtures are said to be heterogeneous. So heterogeneous in simple way, composition is not uniform throughout, is said to be heterogeneous. And homogeneous means the components are uniformly distributed. This is how we can define homogeneous mixture and heterogeneous mixture. This is the first part of chemical classification of a matter. One is mixture. So I think now you can define the mixtures very easily. Types, homogeneous and heterogeneous. If you come for other part, that is a pure substance. This is very important. Majority of us get confused over elements, compounds, atom and molecule. The entire chapter stands on this topic: elements, compounds and molecules. Start with a simple thing, elements. So Okay. See, we discussed mixture. Now we are discussing pure substances. As the name itself states, pure substance means it is made up of only one type of substance is said to be a pure substances. Under pure substance, it is further classified into two types. One is elements. Another is compounds. What is the meaning of element or elements? See, if you take a matter, anything, any type, it is made up of elements only. These elements are nothing but these are the substances which is made up of only one type of atom. Only one type of atom. It may be a particles or it may be a molecules. These elements may be in the form of atomic state or it may be in the form of molecular state. I will tell a simple example. So for an element, see, we are using a word oxygen. Regularly, it's a routine. Because oxygen is the major constituent and it is very much required for the life. Okay, oxygen is very familiar to you. So if I ask oxygen, see, if I ask oxygen, you say it is a gas. No doubt, it is a gas. Because of physical appearance or its physical property, you are saying it is a gas. Even liquid oxygen is also there. We can discuss it later. Oxygen. See, this oxygen I have written O2. Whether it is a compound or element is a question. If you are telling it is an element, what are the properties required to state it is an element, or which are the properties required to state it is a compound? This is very important. Look here, oxygen, it is made, I have written 2O. Oxygen is symbolically written capital letter O. O2 means two oxygen atoms are there. These two atoms of oxygen which are combined chemically to give O2. In this you will find only the atom of oxygen. You won't find any other thing apart from oxygen atom. Hence it is said to be a pure substance. So element is a substance which is made up of same type of atom or same type of atoms combined to give a molecule. So O2 is a molecule, O is an atom. So it is oxygen atom. These two atoms of oxygen combine to give a molecule of oxygen. So if you take an oxygen, you find only the atoms of oxygen. In the same way, I will take another example. Very simple example. It is most common to us, iron rod. You take iron rod. See, if you are telling iron, why you are telling iron? You can tell, you can say it's a gold. You can say it is a magnesium or sodium, but you are telling iron. What makes you to say it is an iron? Because these are the metals which differ from each other with respect to chemical and physical properties. Then what makes to say it is an iron? The reason this is made up of iron atoms. So if you take an element iron, this element iron is made up of only iron atoms. You won't find any other atoms like gold, magnesium or sodium. So why you are telling it is a pure substance means if you take a pure iron rod, you can find only the atoms of iron, no other substance, no other components. Hence it is said to be a pure state. For example, you take sodium metal. If you take a pure sodium metal, this also made up of atoms. I am using the word atoms only, but the atoms of sodium is differ from the atoms of iron structurally. So whatever the atoms present in the iron is not same as the sodium. The structural non-identical properties makes difference in chemical and physical properties of the substances. Okay, so iron and sodium. Now iron is element, sodium is element. In the same way, you take copper. Copper is element. Oxygen is element. Hydrogen is element. Then nitrogen is element. The reason the hydrogen you are saying it is an element because it is made up of hydrogen atom. Oxygen is an element because it is made up of oxygen atoms. Nitrogen, it is made up of nitrogen atoms. How these elements exist is the question. Do you say oxygen exists in the form of O? I say this is the representation of oxygen. In nature, oxygen exists in different way, that is O2 form and O3 form. It's a pure substance. Here the two oxygen atoms are combined. Here the three oxygen atoms are combined. Three oxygen atoms are combined. No other atoms you can find here. Hence it is said to be a pure substance. That is one part. If you take helium, take helium, how we are representing Hg. Oxygen, I wrote O2. Hydrogen, I wrote H2. Nitrogen, I wrote N2. Can you make any difference here? Yes. One difference you can observe, you take helium. These are all pure substance, no doubt, because you won't find anything apart from a particular atoms here. Helium and oxygen, if you compare, helium is also gas, oxygen is also gas. What is the difference? The difference is representation. Have not written He2 or He3. I have not written like this. Simply I wrote He. Why? What is the reason? The reason is simple. Helium is a gas. It does not combine with other helium atom to give He2. It is said to be atomic form or free form. It is said to be free form. In the nature, this element exists in the form of He, not in the form of He2 or He3. But oxygen is also an element. It does not exist in O. It is in the form of O2 or O3. This is called combined state. Nitrogen exists in the form of N2. The two atoms of nitrogen combine to give N2. Two atoms of hydrogen combines to give H2. Two atoms of oxygen combines to give O2. So here these elements exist in the form of a molecule. Now, what is the meaning of molecules? Usually, synonymly, we are using compound and molecule. That is wrong. Molecules are the substances in which it is made up of a same type of atom or a similar type of atoms combined to give the molecules. So, O2 is a molecule, H2 is a molecule, N2 is a molecule, He is atomic state. Atomic state means it has not combined with other helium atom. It exists in the free state. It is also said to be elemental state. Elemental state. This is how the elements are defined and existence can be explained. So then now tell me, what is an element? Element is a pure substance in which it is made up of same type of atoms. No difference or no changes in the structure of atom of a particular element. It is said to be a pure state. It is said to be pure state. So this is one part, elements. The thing is, you are supposed to learn the first 30 elements and its atomic number as well as mass number. This is very much required for mole concept and stoichiometry. Later it will be discussed one by one. Let's go for another topic, that is compounds. What is a compound? Usually we use a compound in the chemistry. It is a routine. What exactly the compound means? Compounds are the substances. It is also a pure. But the difference you can see, it is made up of two or more elements. The two different elements combined in the fixed ratio. Two or more different elements combined in definite ratio by mass. Usually it's a fixed ratio, we can see in a simple word. Definite ratio by mass is the appropriate one. So what is the meaning? So take a simple example. You will come to know very easily. See, compounds. CH4, HNO3 and O2. Take these three examples. First case, I have written O2. It is very much clear. This is molecule. Why you are saying it's a molecule? Because two atoms of oxygen is combined. It is an example for element oxygen, because in this case you find only atoms of oxygen. It's a molecule. Okay. Come to second example. Have written CH4. What is the meaning? Don't think about name and all. Just look into this example. Have written carbon and 4 hydrogen. See here. Is there any difference between these two? Yes. Major difference you can find. Here you have two elements. One is carbon, another is hydrogen. These are the elements. If I ask how many atoms of carbon, you can say 1. How do you say? In this formula, I have written only 1 carbon. So you say it is 1 carbon. If I ask how many hydrogen atoms, you say it is 4. Because it is mentioned 4 hydrogen atoms. Now look into this. It is made up of 2 elements. One is carbon, another is hydrogen. Is it carbon atom and hydrogen atoms are same? No, they are different. Carbon is a different element, hydrogen is a different element, but it is combined in the fixed ratio. So the two or more different elements which are combined in the fixed ratio, they are said to be compounds. We can't say it is a molecule because different atoms are there, different elements are there, so it is said to be a compound. Okay, fine. So if I ask you a question, how many types of elements present here? What is the answer? Two elements. Which are those? Carbon and hydrogen. Come to next one. Look into this example. I have written HNO3. Don't think about name. It's a nitric acid. So, how many elements you can see? Looking into this symbolic representation, this is hydrogen. This is nitrogen. This is oxygen. Then hydrogen is one element. Nitrogen is another element. Oxygen is another element. So there are three different elements which are combined in a fixed ratio to give compound. Here, if I ask you a question, how many elements in the nitric acid? You say three. One is hydrogen, another is oxygen, another is nitrogen. So here, how many elements in oxygen molecule? You say only one, that is O, oxygen only. How many elements in CH4, that is a methane? You say it is a two. One is carbon, another is hydrogen. See, this is how we can differentiate elements and compounds. This is also pure. If you take a methane gas, you find only CH4, 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 CH4 in millions. It is not mixed with any other substances. Hence, it is said to be a pure substance, but it is a compound. It is a compound. You take another simple example. This is very important thing. Most familiar is H2O. What is this? It's a water. You take container, take water. It's the purest form. No other substances are added. It is in a pure state. In this case, you find only millions of H2O, H2O, H2O. Hence, it is considered to be a pure substance. But it is not an element. The reason this H2O is made up of two different elements. One is hydrogen, another is oxygen. Hence, it is a compound but not element. This is how we can differentiate matter into two types. One is a mixture, another is pure substance. Under mixture, we studied two things. One is homogeneous. What is a homogeneous mixture? Homogeneous mixture is one where the composition remains same throughout the solution, is said to be homogeneous. Heterogeneous means different composition at different level or different regions or different place is said to be heterogeneous. Non-uniform composition is said to be a heterogeneous. If you come for a pure substance, two types we have. One is element, another is a compound. What is an element? Element is a substance which is made up of only one type of atoms, is said to be element. Elements exist in the form of atoms or it may be in the form of molecule. Example for atomic type of elements means helium. Helium exists in the form of He, it does not combine with another helium. Neon, argon, krypton, these are all noble gases. These gases exist in the free state. It is said to be elemental state or it is said to be atomic state. It also, some of the elements exist in molecular state. Example, O2, N2, H2. This is a molecule. This is a pure substance. When you come for a compound, what is a compound? Compound is a substance which is made up of two or more different types of elements which are combined in the fixed mass ratio is said to be compounds. Example, water is a compound, HNO3, nitric acid is a compound, carbon dioxide is a compound, H2SO4 is the compound. This is how the matter is classified. So let us discuss rest of the topic in the next session. Thank you for listening.